the pattern that you have decoded from the beacon channel into the USRP, and it does the hopping. There is another approach where you just typically, at least in not too big cells, let's say you have 4 or 8 frequencies that are being hopped. So since the receiver front end is relatively wideband, you can capture all of them at the same time and then implement the hopping in software. Because if you capture wide enough that all the frequencies that it is hopping are inside your capture, then you can use filtering to select the individual parts in there. But to my knowledge, at least in the Airprobe and THC GSM project, nobody has implemented either of those 2 approaches yet. Yeah, it's a question over there. So the question was whether the hardware supports multiple frequencies for TX and RX. And yes, the USRP hardware, the USRP version 1, has 2 different versions of the hardware, but both are available. It's not like one is phased out. The version 1 of the USRP board has 2 receive and 2 transmit sockets for front ends. So you can put 2 modules for receiving on the board, and you have 2 analog digital converters, so you can simultaneously receive on the uplink and on the downlink channel to actually decode both at the same time. So the hardware has the capability. Software, once again, is not there yet. We're still at the downlink. Uplink is next step. Frequency hopping will follow afterwards. So once again, if you are familiar with communication systems, if you have any idea about signal processing, and you're interested in helping this project, there is still a lot to be done, and we're very happy for any contribution in Airprobe. Next question.
Maybe I missed it because I missed the first few minutes of your presentation, but did you also cooperate with the OpenBTS project, which also uses the USRP and also uses that as a base station for GSM in software?
Yes, I'm very well aware of OpenBTS, and I'm in close contact with David Burgess, who develops OpenBTS, and we have a lot of exchange of ideas and whatnot. I personally believe the architecture of a BTS does not contain too much that can be used for passive surveillance. The reason being that the BTS is the clock master. No. It does not synchronize to any other signal, but it emits the synchronization sequence to which everyone else, both the actual receiver and any eavesdropper, have to lock onto the signal. So if you develop a passive sniffer, then it has to synchronize to the BTS. It has to lock on a different signal, which is similar to a handset side, mobile station side implementation, not so similar to a BTS side implementation. But yes, generally there is a lot of exchange, and we're in good contacts, and that's very helpful. Yeah. Okay, I suppose the last question, because before we go to the next talk.
All right. Just a question if there's been already any hardware developments making custom hardware to help debugging or decoding the protocols.
Okay, so if I understood correctly, the question is whether there's any specific custom hardware for doing the decoding and so on.
Yeah, that has been developed by quote, us, unquote.
Yeah, as to my knowledge, publicly in the open source, open hardware community, there has not been any such custom development.
Is there, sorry, I'm interrupting. Is there a regulatory issue with that?
No, there's no regulatory issue with that. I mean, regulatory issues arise mostly when transmitting is involved, and if you want to build custom hardware for receiving signals, there's no regulatory issue involved with developing the hardware. You might not be able, or might not be legal to use the hardware on commercial networks, but as long as you use like it for debugging OpenBTS or something like that, then it's a perfectly valid reason. Yep. Now, as far as custom hardware goes, the problem is that you would have to all the integrated solutions, once again, you do not get access to them, right? You do not get access to the components, you do not get access to the documentation unless you're a handset maker who pushes tens of millions of units. Yep. Now, you could obviously build it in hardware using more traditional approaches, using hardware demodulation and a small DSP who decodes the signal in the baseband, like a traditional GSM receiver architecture. But then I don't really see the advantage of that. Yes, you can make the per unit cost cheaper. So rather than having to spend 1,000 whatever euros on the USRP, the custom hardware you can probably buy for like 100, 200 euros hardware cost. So it's mainly a cost optimization thing. But as far as complexity of development is involved, it doesn't make the problem any easier. You have to debug the electronics, you have to do a couple of PCB versions, all the involved people have to get the latest prototypes. So it's a lot of, it's much easier to tackle the problem in the software space than in the hardware space.
Yep. You mentioned also the downsampling?
Sorry,
You mentioned downsampling done to be able to cover because there aren't any components to digitize the full frequency signal?
It's the acoustics here completely. I'm sorry.
So should I just
Yes, please, don't speak to the microphone.
All right. You mentioned downsampling the analog signal in order to more easily be able to digitize.
No, it was not downsampling, it was down converting. Right? Downsampling is just reducing the sample rate. Down converting is, you take the 900 megahertz, you shift it down to 10 megahertz. You take a spectrum out of the 900 megahertz, like 500 kilohertz width or 200 or whatever you want, and you shift it down to 10 megahertz. So your analog digital converter doesn't have to run at a sample clock that's, like whatever.
And that is currently done in hardware already?
That is done by the USRP hardware, yes. The receiver front and what is here, the RFX 900 board, it takes the 900 megahertz, it down converts it into actually baseband. It's a zero IF IQ down converter. And then you have the I and Q components which are fed into 2 channels of an analog digital converter. And then of the resulting signal, you can do a digital additional down conversion or resampling or anything still inside the board, and then it leaves the actual system and goes to the PC. So this is for the low-level technical details.
All right. Thanks.
Well, thank you.
Okay, so we continue in approximately 5 minutes with GSM decryption so that everybody can get a drink and be back here in 5 minutes.